In today's video, I will show you how to solve this problem. So the problem is to calculate 25 minus 5 divided by 5, and it claims that the result is 4. So let's calculate this. What we have to do in this problem is to take care of the order of operations. We have subtraction and division. As the order of operations is concerned, we have to do division first and then the subtraction. If you are not sure how to easily remember the order of operations, you can use a simple acronym PEMDAS. Acronym PEMDAS stands for parenthesis, exponents, multiplication, division, addition, subtraction. An important note here is that when we come across the operations which have the same priority, like multiplication and division, or addition, subtraction, we do them from left to right in the order in which they are written. In this problem which we have 25 minus 5 divided by 5, we only have subtraction and division division has priority over subtraction. So this is the part which we have to do first. So then we get that this is equal to 25 minus 5 divided by 5, which is equal to 1, and then the final result is 24. As you can see in the claim of this problem, it insists that the result is 4. The question is, what is that all about, when we can clearly see that the result is 24? So the way in which I have shown you how to deal with the problems like this one is the correct way. There are no mistakes in the calculations performed so far. So what is this 4 all about? The question now is, what if someone who wrote this problem forgot about the order of operations? Let us see what happens in that case. So we have 25 minus 5 divided by 5. If we ignore the order of operations and just calculate everything from left to right, we are going to calculate this part first, and we get that 25 minus 5 is 20, and then we have division by 5. And that is finally going to give us the result of 4. Now remember that this is not the correct way of doing the calculations. Yes, we did get the result of 4, which we are looking for, but this is just wrong. Let me cross this here as it is wrong. It's just incorrect, and I'm just not going to allow this approach to even be taken into consideration. So what does the problem writer want us to do? It says here in the beginning that the result is 4, but as we have this exclamation mark behind the number 4, that could also be 4 factorial. So if you have, for example, 5 exclamation mark, in mathematical context, that is 5 factorial. And the factorial means that you are looking for a product where you start from the number given and calculate the product of all the numbers down to 1. For number 5, this is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, and the final result of this product is going to be 120. So 5 factorial is equal to 120. So let's calculate the 4 factorial now. We have 4 multiplied by 3 multiplied by 2 multiplied by 1. And as you know, 4 multiplied by 3 is 12, which multiplied by 2 gives us 24. And when we multiply 24 by 1, we get only 24. So this is correct what the writer of this problem claims. Indeed, the result is 4 factorial. And as you can see here, The writer of this problem claimed that the result is 4 exclamation mark, so this exclamation mark is actually the factorial. So this is correct. Looks like that it depends on how you read it. The factorial is a great thing and broadly used mathematical concept. So let's talk a little bit about it. So if you have never heard about factorial, I can tell you that factorial is used a lot in mathematics. For example, if you want to arrange 3 people in a row, so we have the first person, and then let's take the green pen for the second person, as these are all different people, and finally a red for the third person. For example, if you want to arrange 3 people in a row and you want to know how many possibilities there are to do something like that, then you can use the factorial to calculate that. So before jumping to the use of factorial, let's see how many ways of arrangement there are. So let's take our 3 people and assign them numbers. 1, 2, and 3. So this arrangement is one possibility. Another one is to change the order of the third and second person. So we have 1 who remains at his position and then 3 and 2. Another possibility is that the second person is first, and then we have the other 2 like this, so 2, 1, and 3. Or we can switch these 2 last ones and we get 2, 3, 1. Like so. And same with the third person, so 3, 1, 2, or 3, 2, 1. So these are all the possibilities and we have 6 of them. And it would be a lot faster to use a factorial to calculate these 6 here in the result. So let's approach this problem from a different standpoint. So you have 3 people and you look at it this way. They have to be arranged in these 3 spots. So for the first spot, there are 3 persons competing. So let's write 3 here. For the second spot, there are now 2 people competing. As one person can't be at the 2 different spots at the same time, so you have 2 here. And finally, you have just 1 person remaining for the last spot here. So what you get is 3 multiplied by 2 multiplied by 1, which is 6 when you calculate it, and you can write this down as 3 factorial. If you have larger groups of people, you can just use factorial, as it is going to become increasingly harder to write all the possibilities which exist. A little important note here, which I want to make, is that 0 factorial is defined as 1. If you think about this, you have 0 people in a row, so no one is there. Then you have 1 possibility to arrange no one in a row, as the row stays empty. That empty row is 1. I have one video on this topic of why 0 factorial is defined as 1, and if you want to watch it, I have linked it here in the description. I hope that you have enjoyed this video, and if that is the case, please leave a comment, as I love reading those. Please like, share and subscribe to the channel. Lastly, I want to recommend to you this video to be watched next.